Hello everyone. So continuing on our sampling and data, just let's do some recap of the things we talked about in the first session in this chapter. So we said, what is statistics? Now, statistics, it is the art and science of learning from data, which involves determining a research question, planning data collection for study, collecting, analyzing, interpreting the data, and then presenting the findings. Some examples could be like average amount of TV watched per day, or median height of women, range of hand spans, or percentage of people who are concerned about global warming. Then we started with two very significant terms in statistics. There were population and sample. Population basically means every possible entity or a subject which is involved in a research topic, and sample is a subpart of a population. So here's like population is like this big huge circle, and if I take small parts of it, so pick up these data and I collect them, that becomes another sample. So this is sample 1. So if you collect them, this becomes a sample 2. So sample is, as I said, is a subpart of a population. Let's look at one simple example. It could be the prediction of the outcome of the 2010 the gubernatorial elections in California. An exit poll sampled 3,889 of the 9.5 million people who voted. What would be the sample? The sample would be 3,889 people. And the whole population for this exit poll would be 9.5 million people. Now we're going to look at two more specific key terms. They are parameters and statistics. Now, what is parameter? A parameter is a numerical summary of the population. In other words, if we summarize a data in form of a number or something, for example, proportion of all teenagers in the United States who have smoked in the last month. So basically looking at every possible teenager and a proportion of that who have smoked. Whereas a statistics is a numerical summary of the sample taken from the population. So be very, very vigilant. This statistics, which in reference to the way it is being used, is a numerical summary of a sample. And when I say the word simple statistics, statistics is the art and science of learning from data. So there are two different interpretations of the same word. Depending upon the context of what you're looking at, that's how you make the difference. So if you're looking at some numerical summary of a sample taken from a population, that means you're looking at statistics. For example, a proportion of teenagers who have smoked in the last month out of a sample of 200 randomly selected teenagers in the United States. So the moment you see a word sample in the description of your statement and there's some numeric summary attached with it, like here the numerical summary we are talking is the proportion of teenagers. That becomes a statistics. And as I said, be very vigilant and careful of where the word statistics is being used. That's a key point. Now, so let's look at some more examples over here. Now, if you want to know the average or mean amount of money the first-year college students spend at San Jose College on school supplies, which does not include books, randomly 100 first-year students at the college were selected, and 3 of those students spent $150, $200, and $225 respectively. We would like to find the parameter and the statistics in this problem. So the parameter over here, now remember parameter means the numerical summary of the population. So here the parameter is the numerical summary. Remember, it is the average amount. Do you see this one? But whose average amount? So this is the average amount of money spent by a first-year college student at San Jose College, SJC, except that or except books. Okay, so basically parameter, as I said, the word parameter means the numerical summary, and over here the numerical summary is average mean. So what would be the statistics? Now remember, statistics is related to the numerical summary of the sample. So in our case, what is the statistics? Again, it's going to be the average amount. So the statistics is the average amount of money spent, excluding books, of the 100 first-year students here. At San Jose College. Okay, so looking at the sample set here. Okay, let's look at another example. In our University of Wisconsin-Madison study, 100 of the 40,858 student body members were asked, on how many days in the past week did you consume at least one alcoholic drink? Also, one parameter of interest is the proportion of student bodies that would respond 0 to this question. Now, suppose 29% of those who were sampled gave this response. Now, the moment you're seeing 29 and 29% of those who were sampled. Now, is this numerical survey of 29% a statistics or a parameter? So when you're reading this second last sentence, suppose 29% of those who were sampled, that automatically is a giveaway that this numerical summary is a statistic. Now, there's another key term in our statistics studies, and that's called the word variable. Now, variable is a characteristic of interest of for every person in a specific population or a sample we are doing, suppose in a research study, and it is most of the time denoted by a capital letter, say capital X, Y, capital Z, whatever you like. So remember, variable is a characteristic of the population or the sample in a research study. So let's look at an example here. We would like to determine the variable. We would like to know the average amount of money first-year college students have spent at San Jose College on school supplies which do not include books. Randomly, 100 first-year students were surveyed at the college, and 3 of those students spent $150, $200, and $225 respectively. Now, what could be the variable? One of the variables could be the amount of money spent excluding books by a first-year student. So we say, hey, let X, capital X, be the amount of money spent excluding books by a first year. So by first year students attending San Jose College. Now we have to go a little deeper into it. What kind of variables are we dealing? Are they always going to be numeric, or they can be non-numeric too? So we have two kinds of variables. We have numerical and non-numerical, which we give the terminology categorical. So numerical variables, as the name suggests, they're going to take some numbers or values, such as weight in pounds or time in hours. Categorical variables, it means something which will not have any numerical value. It would be like a place or a thing, like yes or no in a questionnaire or survey, true or false. So those kind of things. So let's look at some examples here. For example, if you let X equal the number of points earned by one math student at the end of a term. Now, the moment you see the word number, automatically it is a numerical variable. So the capital X over here is a numerical variable. Second would be if you let capital Y be a person's party affiliation, then some examples of capital Y could be, say, Republican, Democrat, Independent. Now, clearly, you do not see any numbers. You're seeing a word, so that is a categorical variable. Now, another two things we will be seeing in the statistics class of ours is mean and proportion, a very important concept for us, guys. So we will be looking at that. So just to give you an idea what we mean by a mean, mean is simply an average. For example, if you want to look at the average of all the exams, it was taken in a math class. Suppose if you took 3 exams in a math class and obtained the scores of 86, 75, and 92, you would like to calculate your mean score. And how do you calculate your mean score? You add these 3 exam scores and divide by the number 3. So in this sense, what is the average of your math scores? It is nothing but 86 plus 75 plus 92 divided by 3. When you do the math, you get that answer to be equal to 84.3. Another way of looking at this, as I said, proportion is one of the big things we would be doing in this statistics class. So if in our math class there are 40 students and 22 are men and 18 are women, then the proportion of men's students in this math class is 22 over 40. And the proportion of women students is 18 over 40. And later on, in later chapters, we'll discuss more about means and proportions. Thank you.